listen to the silence of space. Tonight, we will fall asleep to stories about the space station and those who work there. Just close your eyes and let the voices from NASA take you to the stars.
Houston, we have a podcast. Welcome to the official podcast of the NASA Johnson Space Center, Episode 8, Exploring the Cosmos. I'm Gary Jordan, and I'll be your host today. So this is the podcast where we bring in NASA experts, and in the case of today's episode, some super cool space fanatics to talk about everything NASA. So today we had quite a few special guests. We're talking about human space exploration with Glenn Lutz, John Connolly, and the band Styx. Glenn is the Deputy Director of the Exploration, Integration, and Science Directorate, or EISD, here at the Johnson Space Center. John is the head of NASA's Mars Study Capability Team under EISD, and Styx is a rock band. We talked to Tommy Shaw, who does guitar, vocals, and a lot of the writing, and Lawrence Gowen on vocals and keys, and also does some of the writing too. Why is a rock band here at the NASA Johnson Space Center? Well, we have a lot of amazing things to show off, and sometimes people come over to check it out. We had a great discussion about exploring the cosmos, what human exploration missions will look like in the future, and why we send humans to space in the first place. So with no further delay, let's go light speed to our talk with Mr. Glenn Lutz and Mr. John Connolly, as well as Mr. Tommy Shaw and Mr. Lawrence Gowen from Styx. Enjoy.
T-minus 5 seconds and counting. Mark. All launch commit lights are correct. There she goes.
Houston, we have a podcast.
Okay, so, how you guys liking the tour so far?
Do we have to leave?
Yeah.
It's a mind blower, is what it is.
Yeah.
It's a mind blower, and getting to meet people that do this every day is that's an honor, and that alone, But then seeing them with the machinery is, I can barely form words to describe how overwhelming it is.
What makes it so overwhelming, though? Is it just the history, or is it just the amount of stuff? Maybe
It's kind of everything,
Okay.
Just from being a child, and I still remember Sputnik, and so I followed it. Our family would always follow everything that went on, and up until modern times now. I mean, all through our lives we've watched it, and then now to do we did a little story ourselves about it, and it involved some trying to get it right so it would be feasible, and now to see these the hardware that we were just sort of imagining,
right?
To see the Orion, that was amazing too, but also to see the control room that we'd all seen as a child. It's it really is. It's kind of overwhelming.
Yeah, mission control, right? A lot of history there, like this, and like we were talking about it on the bus, right? You're sitting in a room and you're thinking about all the great things that happened here. You're talking about landing on your moon. You're talking about learning how to fly humans in space, all from this room.
Yeah, the command center that basically of the greatest human history that's unfolded in our lifetime. So to be at the epicenter of that and drink in, and as Tommy just pointed out, it's something we've had since we were children.
Right.
So you're in touch with your entire. This might be overly philosophizing about it, but it's I can't even speak.
Overly philosophical.
Overly philosophical. Thank you so much, Gary. I needed that.
That's what I mean. It's been a long day. Yeah.
It's this weightlessness condition that I'm in. You're in touch with all of that, and the fact that you're so close to this, what is the greatest human endeavor, in our lifetime, and all that's ensued because of it.
Absolutely. So what was so exciting, I think, for us from our end, is to show you not only the history of kind of what we've been doing here at the Johnson Space Center for so long, but also kind of what we're going to do, right? Like you said, we're showing you Orion, we're showing you exploration. We're already talking about Mars, the moon, going beyond the low Earth orbit, and we're kind of excited to show you that. So, I mean, just in terms of human exploration, just exploring, going out, seeing what is beyond.
Yeah.
What do you think is that drive? Why do we have this drive to explore space as humans?
It's human curiosity.
I think so.
What else is there? We've done this. What's out there?
Yeah.
And we keep finding out a little bit more, and I realize how serious that quest is here. But for all those questions, there's all this detail and all this research and wanting to get it right here so that it's right when you're out there.
Yeah.
Just seeing all the manpower and all the research and development is kind of mind-boggling.
It's the most extreme example of how human beings have this built into our DNA. This what else is the question? Like, what else?
Yeah.
And as I'm walking through there, even looking at all those various vehicles, it's like, what else could you do with a vehicle that would work in a place that we don't know about yet? So I guess that's really another thing that separates us from any other form of life, is that we're driven in that way, not to stay safe, but to do things that are risky and hard. I'm going to start quoting John Kennedy or Captain Kirk in a minute. But anyway, it's great to be close to that.
Sure. Yeah. But I think maybe it's that human element, right? It's that passion that really drives us, and maybe it's kind of built in our DNA to want to explore. Maybe that's why we send humans. Humans can tell a story when they explore that I don't think robots can. It's that personal, the human element that we connect to.
Well, that's it. What was it like?
Yeah.
And you can't, no matter how great your artificial intelligence is, it can never convey exactly what was it like.
Exactly.
And speaking to Dan, astronaut Dan Burbank, he was able to, in very short order, give you a sense of what that felt like.
Yeah.
Yeah.
So just from his personal experience, you can't get that from data from a robot or something. You feel what he's feeling, sort of. You're there.
And when he described some of what he had to go through to do it, I'm glad I didn't have to go through it. I'd like to just live vicariously, enjoy it.
Well, I think what's fantastic is so talking about human exploration, this is not something that is kind of brand new. We're just thinking about it. We've been thinking about it for a long time. In fact, we have people here at the Johnson Space Center dedicated to thinking about exploration. So I want to formally introduce two folks that we have with us today, Glenn Lutz and John Connolly. Thank you so much for being here. You are part of our exploration group in a sense. So talk a little bit about what you guys do.
All right. Well, we are put in place to do just that, take us to those next steps.
Mm-hmm.
So John's in charge of putting out the plan, and he's got a group that's making sure that everything that we need to go to Mars is thought about. There's not a CVS or Walgreens on the way to stop and pick up something. So these guys are in charge of putting that whole plan together, from number of rockets, how we're going to live on Mars. We've got guys in our group that are working on technology gaps. What works today and what we need, and there's a gap, so we're closing them in testing and etc. Our group also has the scientist in it, and so they're saying, okay, why?
Mm-hmm.
Why are we going? And where are we going to go to make sure that we take the best advantage of where we're going?
Yeah.
So Tommy mentioned that, as kids, we all kind of watched the Apollo program, looked up in the sky, saw Sputnik, and I think that's what got people like Glenn and I here in the first place. We were turned on by that and kind of made that our life's calling. And we've been looking at how we get people beyond low Earth orbit, perhaps back to the moon, perhaps onto Mars, as soon as we can. And that's because we all think that human exploration is a fundamental part of being human. Pushing outwards into the stars. And so we do have plans to do it. So that mission control that you saw, where we did all those great things back years ago, the best is yet to come.
So, Tommy and Lawrence, just from your perspective, just seeing what you saw today, and maybe these, some of the folks that have been talking to you today kind of got your mind jogging about Mars, and you thought about Mars in the past just from your writing and stuff like that. So, in terms of Mars, what do you think it is that is so intriguing? Why would we want to send humans there, in your eyes?
Well, it's been the subject of all different kind of creative writing, from the Martian Chronicles, where it was literally little green men, to the book that became the movie, The Martian.
Right.
And so it's really been, and cartoons when you're growing up. The Little Green Men and Mars, and you can, and it stands out. It's distinctive in the nighttime sky because it's red, and you do get to see it a lot. And I guess it's relatively close compared to what else is out there. So there's all of those things from fiction to fantasy and real research and all those things. We're just fascinated by it. And the one thing that strikes me is just how the more we see of things, how kind of small and insignificant we are compared to what we thought of when we were children. You know, the world just seems so magnificently large, and I used to just look up at the clouds and go, how far up is that? You know? And now to see what you're planning on doing here, it's awesome.
I know a lot of the astronauts, and I'm not sure if Dan Burbank brought it up kind of in his talk, but they have something called the overview effect. Being up 250 miles, you have this view of the planet. You see this thin line that's around the planet that's just protecting us, and that's it. And you kind of have exactly what you're saying, that effect of, wow, we are so small. This planet is not as big as I thought. We're all connected, but you know, there's so much more to this universe and to the Earth, I guess.
Yeah. Someone said something about being on Mars and looking out and not being able to find Earth. Which one of us is Earth?
Right.
Yeah.
It'll be the blue one, actually. You should be able to pick out Earth, just like we could pick out Mars in the sky. Earth will be a little brighter, a little bluer than all the other things out there.
So, John, there have been images from the surface of Mars. Can we see the Earth? Is it blue in the sky?
Yes, we can.
All right.
You could see the Earth from Mars. With not much help, you could actually pick out the moon next to it.
Oh, wow.
So
with the naked eye.
Yeah, so while you're, well, it depends how good your eyes are.
Well, from the,
inside the spacesuit.
Inside.
So yeah, when you're on Mars, you'll be able to look at home.
Amazing. Yeah. So I mean, kind of bouncing off of Tommy's point of you know, it being in our mind to explore Mars from a practical sense, from your guys' perspective in the exploration group here at the Johnson Space Center. What are we thinking about? Why Mars?
Well, because it's next. It's the next logical place to send humans. It's the most Earth-like of the planets. It's a place that has incredible scientific value. It may have harbored life in the past. It may harbor life still. Those are huge questions. You know, those answer some of those big fundamental questions that we've had, like, are we alone in the universe?
Yeah.
And it's attainable. I think maybe that's the biggest reason to go there, is because we have the technology now or in the next few years that we could put together a mission and go there.
Actually, I have a question for you.
Yeah.
From what we know about Mars so far, is there any fossil record yet where they've gone down and checked, well, here's what happened during this time, and have they seen anything that... So
we've actually not really explored the Z dimension on Mars.
Right.
Okay, we've roved across, the surface. And one of the things that's on the scientists' plans is to get a drill to start drilling cores and look at things like that. Probably the only fossil we may have seen are some fossilized, what we thought at the time were fossilized bacteria. Back about 97, there were a few folks who thought they saw some remnants of bacteria, very, very small stuff.
Right.
But we haven't really drilled down to find any trilobites yet.
Right.
So from a planning perspective, if you were to plan, that's what you do. You think about planning a mission to Mars, right? What are some of the key elements that are vital to make a successful mission to go to Mars?
So it's a pretty long list. So you need a propulsion system that will accelerate you out of the gravitational pull of Earth. You need a habitat that's reliable enough to take you on a 6-month to 12-month trip to Mars. You need a landing system that'll take you through the Mars atmosphere and down to the surface. You need all the surface equipment, like the rovers that you guys were just in, and the spacesuits and the habitats and equipment to use Mars resources. And then you need a ride home. You need an ascent vehicle to get yourself back off the surface to the vehicle that's going to bring you home again. And so when you put all those together, there's a lot of piece parts that it takes to do that mission.
Amazing. Yeah. Is that true for anywhere we would want to go too, right? You would need sort of a similar profile.
Similar.
Okay.
The moon is actually a little easier than Mars to get to. You don't have to deal with an atmosphere,
Okay.
and it's a lot closer, of course.
Yeah, that
right now,
helps.
the moon's 250,000 miles away from us. Mars currently
A
is
lot closer,
is 250 million miles away.
Yeah.
It's at its furthest point from us right now. It's actually hidden behind the sun. So if you're on Mars right now, we couldn't talk to you.
Oh, couldn't at all, because
No.
I guess the communication
Yeah,
pathway.
for a week or two, you're hidden behind the sun. We literally can't talk to you.
That long, a week or two?
Yeah.
Wow. So what's I'm guessing you're planning for that, right? So what
course.
would be in a situation where that were the case, right? You have folks on Mars and they don't have communication with folks on Earth for a week. What are they doing?
Listening to Styx.
They could be listening to music.
Well, what was it in The Martian? What was the thing? It was Happy Days on the movie, but it was something else in the book.
We got something way better.
Yeah. So our robotic missions that are there now, we put them kind of into a safe mode for a couple weeks.
Oh, okay.
We just don't have them do very much. And in about 2 weeks, we have them start broadcasting until we pick them up again. So the crew would probably have about 2 weeks off, I'd say, where they probably wouldn't do very much.
Do you think the actual shot to go to Mars will launch from the moon or from Earth?
So ultimately, everything starts from Earth. The question is, what's the midpoint?
Right.
So where do you actually assemble vehicles and
Stuff.
things like that? Energetically, it actually makes more sense to assemble things in space rather than on the surface of the moon. So you could do that in lunar orbit.
Right.
You could do that in a very high Earth orbit, but in space makes the most sense. Right at the edge of leaving the Earth's sphere of influence, the gravitational field of the Earth. Then just takes a little kick from there to kick you out to Mars.
Huh.
But you don't want to go into a gravity field like down to the lunar surface, because then you have to fight your way out of that again.
Oh, right.
So what would you be building around the?
We're currently working on some plans for building, for example, the transport that takes crews from the vicinity of the Earth to Mars orbit. And so those are the kind of things you can't launch in one launch because they're too big. So you have to put them together somewhere. And anywhere in cislunar space kind of makes sense to do that.
Okay, interesting.
So it seems like a coordinated mission, venture with lots of advanced things. So you have all the hardware.
Yeah, it's gonna take a lot of launches to put pieces together and get those things sequenced out to Mars in a way that has what you need on Mars when you need it.
And that it's up there and operational before we say, okay, guys, it's time to commit crew to go meet them.
So you think there would ever be a time where when you get all that worked out, so it's just second nature that this is how you do that, to extend that to Mars, so you're building things in Mars to go beyond there?
I think if we figure out how to do it on Mars, that'll be the next giant leap, if you will, and that'll teach us a lot about surviving without being dependent on Earth. And I think that's the next big step.
It goes back to your first comment that even as little kids, you see the 2-year-old, the next thing that's just out of his reach. So if we get to Mars, that'd be the next thing just out of our reach.
So Tommy, kind of thinking about, the next big step. If thinking way out in the future, in your mind, what would kind of be some of the next places that would be really cool to see beyond Mars?
Well, we have sort of a selfish.
I know where you're going here.
On the agenda.
Yes, but it was just bestowed upon the band's name, the fifth moon of Pluto, and we've actually seen pictures of it, and it's not the greatest looking. If you were going to vacation anywhere in the area, you'd go to Pluto, just maybe take some snaps.
Yeah, see it from the surface.
I don't know. I think with a little work, we could buff it up and make it a holiday destination.
It's a fixer-upper, there's no doubt.
It is. It's a handyman's dream. That's what it is.
It's about the size of downtown Chicago, by the way.
Is it?
Yeah.
It's not too big.
Yeah, it's not that.
Chicago's nice.
Yeah. Yeah. I'm thinking
A frozen
In an
Chicago.
unbiased opinion, yeah.
I'm thinking that's the
That's half the
waterfront.
year.
Yeah.
It's come a long way since the World's Fair.
Yeah, there you go. Another thing that, back to where we started here, that blows my mind. When I keep thinking that, one of the airports we go through, I think it's St. Louis. Is that the one that's near Kitty Hawk or where the Wright brothers?
Spirit of St.
Yeah.
Spirit of St.
Is that it? Okay. So I'm thinking that human flight it still boggles my mind. It's just over 100 years ago, and now we're talking about assembling things in space that can reach, the next planet. So that's back to me kind of being mind blowing.
Yeah, I think that's more of like the doing aspect, right? So like, I feel like we've been dreamers for so long, dreaming about the cosmos, and based on our limited knowledge have come up with these fantastical realities of what it could be. But then once we realize that, we can go into space and we have the technology to do it, and you actually build it and do it, that's
why meeting guys like this is so amazing for us.
All right, going way back out to Pluto. You had the privilege of actually seeing New Horizons, right? When it actually took photos of Pluto.
We were invited. We happened to be in the D.C. area on the day that they did their flyby, and we were invited out, and we got to meet the principal investigator, Alan Stern, and all of his people. And they were waiting there for us. I'll never forget. They were there. They had a banner, and they'd all kind of gathered in a room kind of like this.
Yeah.
And they were welcoming us. We didn't know who they all. We'd never met them before.
Sure.
We knew we were at their mission control, but so little by little we started getting introduced. It's just like guys like you who've done this amazing thing, and we realized this is all backwards. We need to have a banner for you.
Yeah, exactly.
It was like we're not worthy kind of thing.
It was like they'd won their Super Bowl. It was on the culmination of a 9-year mission. It was when they were as these pictures were coming through, we were among the first people, Earthlings, to see this unfold. Actually, you just reminded me of something weird about that day that I remember. I remember us getting lost on the way to getting to the
find our way
We
there.
couldn't find our way there, and
We
they
met
spent
the
9 years
navigator.
getting to Pluto.
We met the navigator who
Who actually flew it?
Yes.
Yes.
Wow. Yeah. So how did he describe that ride? Was like I guess it's a pretty intricate ride to get all the way out there.
The only thing I remember is that he said it was about the craft itself was about the size of a baby grand piano.
Yeah.
So directing that through, to all that distance, and it's I guess it's the farthest we've gone, right? So the farthest we've ever sent anything, I suppose. Am I right?
I think
Voyager's a little
Voyager's
further.
even further.
Yeah.
They got a head start.
Okay.
Yeah, but it never took pictures of Pluto. Isn't it?
All right.
That's
yeah.
Well, I don't want to put Voyager down anyway, but to have accomplished that with something. I remember one question I asked that day was, isn't it likely that it's going to be hit by something out there? Because I'm always thinking about I was asking Dan about that as well, and one of the scientists there explained to me that it takes a long time before the concept of how vast space is finally sinks in, that the likelihood of actually colliding with something is so minuscule, that it's incredibly unlikely. And to my mind, it seems like wouldn't that be happening all the time? And apparently, it doesn't happen very much at all.
Even the asteroid belt, I think, is a good example, right? How close are some of the closest things in the asteroid belt?
Well, not as close as the Star Wars movies portrayed it.
That's what I'm thinking. I'm thinking Han Solo going through.
So people think of asteroid belts and the Kuiper belt as being this sort of rock pile in space.
Yeah.
And it's literally millions of miles between little specks of things.
Yeah. So is it fair to say the stuff in the Kuiper belt is even farther away? Like we're talking.
Oh yeah. So that's out beyond Pluto.
Yeah. One of the things I've heard is that we could land on an asteroid, though.
We have that technology to make that happen. In fact, there's one of our ESA brethren across the pond. They did land on a comet.
Oh,
Was that?
Just recently. But we were working missions to put down on an asteroid and see what's there. We've made some course directions and now more focused on Mars now.
Are you talking about a human mission?
No, it was a robotic mission to the asteroid, bring back the piece so that we could study it here.
Got it.
Around the moon.
Okay.
You could land on an asteroid, but it has almost no gravity.
More like rendezvous.
Yeah, most people think that the moons of Mars are captured asteroids, so Phobos and Deimos. You could go there, very little gravity to hold you on the surface, though.
So that makes it a little easier to get to, so you don't have that gravity well that he was talking about to try and extract yourself from.
Right.
Oh, okay. So you can actually just would you in a scenario if you were to visit Phobos, right? If would you land on Phobos and then launch off again, or would you do sort of a orbital
Or anchor, right?
You could do either. You would kind of dock with it.
Yeah.
Oh, okay.
You know, because it would just be kind of another thing floating in space.
So you'd actually have to, by landing, it's more like grabbing it.
More like the boat and the pier.
Yeah.
Next to it, tie on, do whatever exploration you can do, plant the flag.
Okay. Very cool. So I know, kind of going back, thinking about just exploring just different heavenly bodies, right? Talking about Phobos, or even if you were to land on Styx, right? There's something that we like to call ISRU. That's one of the things that kind of we're looking at. In situ resource utilization, right?
There you go.
It's using the stuff that's there to create more stuff. And I guess is the very layman way of saying that.
Right.
Yeah.
So if it was resources,
Living off the land is a
living
good
off the
layman-
land.
is a good layman way
there
to
you
put
go.
it.
Very cool. So where are some of the best places where you can live off the land that we know of in the solar system?
Well, Mars is probably the easiest. Mars has an atmosphere made of carbon dioxide. You could easily crack carbon dioxide into oxygen and carbon monoxide and use the oxygen to breathe or to make most of your rocket fuel. And in fact, we have an experiment flying in 2020 to Mars that's going to test exactly that. So that, and if that works, and it should, because it's very simple chemistry, that means
Knock
that
on wood.
you don't need to take everything with you anymore. When we went to the moon originally, we took everything we needed, every piece of food, every breath of oxygen, every ounce of water. If you find that kind of stuff on planets, that really changes the equation entirely, because now you're living off the land, you're living off the resources of those planets.
Do you think it's possible to add nutrients and nitrogen and phosphorus or whatever to plant
Potatoes?
or
Perhaps.
beans or corn or whatever? You still need oxygen though.
Well, yeah, you need a lot of things. So Mars soil has some of the things you need for growing things. You'd have to add nutrients, and you'd have to wash a few of the other things out of the soil first. But yeah, you could with enough additives grow stuff in Mars soil.
So you could get fuel and food.
Yep.
3D printers. I haven't read enough about them, but is that part of what it is? You take the elements that are there and you're able to fabricate something that whatever is necessary next, or is that where is that?
Yeah, I think 3D printers are on the station today, so we can build something breaks. We don't have to wait and fly up a part. We can build it apart. 3D printers for the fuel that he's talking about, I think fuel is more of a chemical element thing, so we wouldn't really print anything, but we would crack the...
We are looking actually at 3D printers to take like the soil that you could find on Mars, and you add some additives to it, and you use the soil to build habitats and things like that. It would be a big scale 3D printer. There's some NASA technology going on in some of our centers to look at that. So I think 3D printing is in its infancy, and we haven't really even explored all the cool things we can do with it.
So you could make a metal alloy kind of a thing.
Sure, there are already metal 3D printers.
Or even an earthen place to live in.
Yeah.
Out of the soil yourself.
That's what I mean. Like the elements are there to build it. So you could actually, construct something by basically doing it's doing the mining and the manufacturing.
And it helps in a lot of ways in that radiation's a big problem for the human being, and the Earth's atmosphere protects us. We're leaving that behind when we go to these other places.
Yeah.
So if we can build out of Earth, like they used to do in Wyoming, Oklahoma, build the sod houses, so to speak, that helps from that perspective as well. We have added protection than just the spherical dome that we would take with us.
I love it.
And the technology is almost there, or pretty much there, isn't it?
For building houses, 3D
for,
printing.
for doing all those things, and if you get yourself on site,
It's his job to make sure it is.
Well,
So it doesn't seem that outrageous.
no, not at all. That's within the realm of technologies that we could have in the time frames we're looking at to go to Mars.
Is there any sort of I wish I hads that you guys are thinking of?
I wish I had better propulsion. Because right now, as a species, we are stuck in the inner solar system because the best we have is chemical propulsion. We've advanced technology a little bit since Apollo, but and we have things like electric propulsion now. But we need some sort of different propulsion system, some sort of new physics, to really travel amongst the stars or really to get out of the inner solar system. So that's my big I wish I had.
So with chemical propulsion, realistically, if you designed a mission to go like way out in the edge of the solar system, how long is that mission profile to go out to the edge of the solar system and back?
Oh man,
Outside of
it would be a multi-generational.
Yeah. Wow.
And that's the problem with chemical propulsion. It's just not going to push you fast enough to get where you want to go. By the time you got there, another spacecraft would race past you with new technology.
Right.
Wouldn't it be nice where you could just flip a switch and just I'm going light speed and then bam?
Well, can you speculate on what would exist other than chemical propulsion then?
So right now we use, we combine chemicals, we accelerate ions to push ourselves around. That all requires us to have a fuel, okay, that we somehow accelerate out the back end of a rocket. The next big step in physics would come if you find a way where you don't need fuel, that you could somehow create force without fuel.
Right.
And there are some technology projects at NASA going on right now that are looking at that. If you're a big fan of Star Trek, that's kind of what warp drive is all about.
Yeah. Can you explain that?
We'll have to get another podcast.
I read something on this astronomy site that I somehow linked to now on Facebook about some experimental propulsion thing because you're pushing off of something to go the other direction. That there was something new that they were, I don't know if these plates or something that somehow created propulsion.
Yeah, and that's the new physics I'm talking about. We need something like that to get that working. And we do have an engineer here in Houston who's working on a propulsion system like that. Some people call it quantum thrusting.
Yes.
It pushes, and they don't really understand why it works, but it's been tried a couple places around the country.
Yeah.
And it's at the point where you have to be very skeptical about what's going on. And but if it works, it could change the whole equation because it doesn't need fuel. It's using different forces that somehow is pushing against something and moving you.
Well,
Again, another podcast.
We hear about gravity assist, right? Okay, so I mean, is it something of that nature where there's some magnetic exchange?
No, it's a little different. Gravity assist that's basically capturing the energy of a planet like Earth or Venus and taking a little bit of that planet's energy and turning it into your energy as you fly by it.
Yeah.
And what's good about that
roller
is
derby around the edge.
Yeah.
You get a little assist around the edge.
Yeah.
But what's good about gravity assist, and correct me if I'm wrong, but it's a good bang for your buck. You don't put a lot of energy into it, and what you get out of that gravity assist is a really big boost.
Right. In fact, most of the times you don't put any energy into it.
Oh wow.
Get captured.
But what you're doing is you're borrowing a little bit of energy from that planet's orbit.
That's incredible.
Yeah.
So, kind of thinking about, going back to Mars for a second. So, back to a Mars mission. What are some of the things that we have to be concerned about to put humans on the surface to make it, I guess, friendly?
Friendly.
Human friendly. What are the things we have to be concerned about?
Well, Glenn could talk maybe a little bit about spacesuits and EVA, but
Yeah.
I mean, from my standpoint, getting people to the surface. So it's all a matter of changing velocities, first of all, right? You have to leave Earth. You have to ride a big rocket. You then have to change your velocity enough to throw you out towards Mars. Then you have to slow down once you get to Mars and make your way through the atmosphere and slow down enough so that by the time you get to the surface, your relative velocity is 0. So all those miracles of rocket propulsion and entry systems that have to happen keep me up at night. Okay. Then once you get to the surface, you need super reliable systems, because at Mars, like you said, you don't have a 7-Eleven next door. You don't have a handyman you could call. You can't send a Soyuz or Progress up in a couple weeks, with some new parts. So everything has to work for the duration of the time you're there, or you have to be able to fix it. And so it's that super high reliability.
Yeah, I think any endeavor across civilization, so logistics. I mean, they take on the Alps. They have a train full of donkeys behind them to get them there. We don't have that luxury, so we're gonna have stuff that doesn't break. And we're gonna have folks that, instead of the super pilot, he's the refrigerator repair guy. He can tear it apart and put it back together and trust that it works, because he's living off of that machine doing its job.
Yeah.
So everything that you have in the grocery, oxygen, etc., you have to take with you or build or supply while you're there.
But it takes good people to do that, right? You need folks that have kind of a variety of different disciplines that can actually work on this.
Absolutely.
So, Tommy, Lawrence, and in your perspective, kind of what are some of the key folks that you would need to bring with you on a mission out to space?
Well, you need someone who's, I would think, an engineer type.
Definitely an engineer,
yes. Who can be skeptical and have solutions. I think you need somebody who's got a great imagination, who can figure out how to get to the next, what the thing is that you're trying to get to.
A leader, yeah, in a way, I guess.
And you need hands. You need helpers who are also who have specialties and special talents of their own, because otherwise you're just a lonely, you're doing it all yourself, it's kind of like, it's a lot like being in a band. We all support each other, otherwise we would just be one person out there with a microphone, and no matter how good you are, there's limits to what you can do then.
I think Styx would sound a little bit different with just one member.
Yeah. I think we talk about the machines that are necessary to do all this, but again, talking to astronaut Dan, I think medical is a huge necessity, because our bodies morph, and have to adapt, and they do adapt and change in their, so that changes the whole equation of what medically is required, as the thing continues on. So I'd say an engineer, a really good doctor, and probably a good drummer, bass player.
I would add a communicator. You need someone who could talk back to the folks on Earth and describe in terms they understand what they're experiencing.
And the other thing is, you almost have to have two of everything, or double training, because that doctor, if he's the guy that gets the problem, somebody else does.
Right. You were telling me something great about or frightening actually, about the dust on Mars affecting your thyroid. That's part of why my brain started moving toward that.
Yeah, we've got to make sure we separate the bad actors from the human aspect of that. And so all the systems we're building, you saw the rover itself, the suit's purposely on the back, so the dust doesn't come in with you. In Apollo, we didn't have that separation. In those days, they used zippers to close up the suit, and dust and zippers don't like each other.
Right.
This just in. And so the suit you saw didn't have any zippers. We've gone away from that now.
Right.
So, and everything's on the back to separate. So yeah, those are the little details that guys that work with John's teams are thinking about on every system.
Yeah, and it kind of helps that we've explored the moon, right? Because we didn't think about, you're going to be walking on the surface, and then, you're going to track all that dust back in the the cockpit or wherever you're going to be flying from. Now we're designing, like you mentioned, it's called the SEV, right? Space Exploration Vehicle, and it's designed where the suits go on the outside of the vehicle, so you never step inside with the suit, right? So that's the general idea. And there's a bunch of different examples like that, right? Where you learn something and some kind of cool new technology that we need to explore a different planet or something comes out of it. Is there anything else that you can think of besides the suits, maybe?
Well, we'll have robots to assist us there. One of the things that about the human aspect of this flight is, robots can go and discover things, and we've got robots on Mars right now discovering stuff, but they really can't explore. They can't. The human brain to see things and communicate back to Earth what they're seeing, or if something doesn't go exactly the way it was supposed to react and do something different. So robots are going to be a big part of the mission, and have them interact with us. And you guys saw some robots today that will be along as an assist, and so we're going to make sure they do their job as well.
So the robots will be helping like a human. So for a mission to Mars, right? How many crew members would probably be ideal to take on a mission to Mars?
So my number is 6.
6.
Okay, and we've done what we call crew skill mix studies over the years.
Okay.
And it's like Glenn said, you have to take a doctor, but you also have to take another person who's medically trained in case the doctor gets sick. You need engineers, you need geologists, you need all the technical. If you add up all the technical specialists, you probably need 25 people. And so then it's a matter of how can you cross-train people to be a doctor, pilot, geologist. Okay.
Wow.
And the best I've seen is that you can put all those specialties into about 6 people.
Wow.
So
that's amazing. I mean, some of the folks from the new astronaut class, right? I actually had the pleasure of talking to some of them, and we went through. I talked with Ann Romer on one of the earlier podcast episodes, and we just went through all of the different folks that we brought on for the class of 2017. We have 12 new astronauts. Each of them does not just one thing. Right. They do a bunch of different things. Yeah. For example, Woody Hoberg is an engineer in 4 different types of. He's like computer science and electrical and aerospace and mechanical. Like he's all of them. And then when you're talking about a doctor pilot, Frank Rubio is a doctor pilot. He flew helicopters and then he did some skydiving, but then also is a medical doctor by training. It's insane. So they're finding these folks that have all of these different specialties. But when you're talking about, scientist / medical doctor / pilot, and then you have all of these different folks that are ///. It's amazing how you have to do
I would recommend being able to play an instrument.
and many astronauts know how to. We have guitars and other things up in space right now.
Yeah.
Because music is really a part of life. And,
absolutely.
And it's one thing to have pre-recorded music, but to create music and make your own music would be part of it. Because you need joy.
Yeah, absolutely.
You're not just working all the time. You need to have the joy of life.
And you're right. Some of the as we were saying, we have progressed from shuttle flights, which were a couple days, all the way up to now International Space Station flights, which are several months. Yeah. So they're up there for a long time, and a lot of them, like you say, they do bring instruments. We have, Chris Hadfield has his guitar, right? He's jam. We have folks bring flutes.
Katie Coleman,
right? Yeah. And then I think Kjell Lindgren brought a bagpipes, right?
They made him practice way on the
side. He wasn't invited back.
You know what? It's funny. Yeah, I think 6 is a good number. There are 6 members of Styx as well, and we are very good at the music part.
Yeah,
we do have a mechanical engineer.
Well, we do. We have one. That's right. JY has a degree in rocket science.
Really?
He does actually.
There you go.
So and just like a band, a crew has to be a very cohesive group of people who get along and know how to solve their conflicts, without leaving the band. Right. Because there's no place to go up there.
There's constantly you're adjusting to things, and you're a lot of times you're working on not enough sleep. The weather doesn't cooperate with you. You're going into these habitats that they're different every day, and different configurations of how our dressing room. Sometimes we're all in one room. Sometimes we have individual rooms. So you have to be adaptable and flexible, and know when you are fatigued and know yourself. And being in a band we're very fortunate to have the group that we have, because somehow we just get through it all, do what we need to do, adapt, and then at the end of the night we get to go play. And that's really what it's all about. You're willing to go through whatever it takes to get there and to get that 75 or 90 or 100 minutes.
Yeah, I think that is what being in a band is somewhat akin to what you're saying. Like you have to keep the focus has to remain on what's bigger than any one individual, and to be able to navigate your way through the human conflict is part of life, and it's part of discovery, and it's part of the friction that brings new things about. But to do that over an extended period of time, as these people would be, a crew of 6 would be faced with, they have to have those kinds of skills in addition to all of those other talents.
Absolutely.
So that's hard to pick those people.
It'll take a while to go through that evaluation. We'll have lots of candidates to line up for those 6 spots.
Yeah.
It's going to fundamentally be a different kind of astronaut than we've had before, just because of the length of the mission and the self-reliance and you don't even communications. You're right now, if we were to talk to someone on Mars, you're 22 light minutes away, one way. So if you were to ask them, hey, can you guys hear me? You won't get an answer back until 44 minutes later. And so even the dynamics of how we control a mission and how we can help the people up there is going to be different. So it's going to be a much different mission than anything we've ever done, even out to the moon.
And I think what's even another important point is the fact that these guys are going to have to be, not only they're going to have so many different types of expertise, but they're going to be together for such a long period of time. So they definitely have to get along pretty well. And in moments of crisis, they have to kind of work through different situations together. And at the drop of a hat, one thing you're planning one way, and then it's going to go a completely different way. Do you guys have any examples on stage where something just was not going according to plan? Every night.
Absolutely.
But you just have to push through, right?
Yeah, and as a band, you just pay attention to each other, and if it goes off the rails, which it does sometimes because you're all human.
Yeah.
Everybody just follows you back off the rails and then back on again.
Yeah.
And you don't let on.
Yeah, there you go.
Yeah, it's a two-sided thing. One is the machinery has to work in order for you to play it properly.
Sure.
But at the same time, we're all focused on the entertainment of the audience as to what we're doing on stage. So that's more like the bigger picture is all constantly being readjusted to.
Yeah.
And that has to be. Some of that's done almost. I won't say it's telepathic, but it's just a natural reaction that you have to each member of the group, because you really are playing together. You're trying to speak as one voice.
Yeah.
So
That cohesiveness is what we got to strive for in our crews.
yeah.
And we'll have international crews, so we'll be mixing cultures as well, but that cohesiveness is what is going to make us successful or an unsuccessful band or a flight.
And that was so evident today about how the United States and Russia have combined, and when they're sometimes at odds with each other is when finally a better solution comes out of a situation like that.
We're practicing that with the International Space Station right now.
Yeah.
12, 13 countries all participating, making that thing a success.
Absolutely.
But the Canada arm came worked for.
So, one of the things is we train on the International Space Station all the time, and we're training for missions beyond and getting ourselves prepared. If anything goes wrong, we'll be prepared for it because we've practiced so many times. And I'm guessing it's the same for you guys, right? You've practiced so many times that if something goes wrong, drop of a hat, you can kind of, that's how you're able to pull through on all these nights.
How about the night in Carmel earlier this year when the power completely went out? 100%. Yeah.
Yes.
And fortunately, we were in a theater that kind of had a almost steeple-like church type thing. So although there were a couple of thousand people there, you could actually hear from the stage acoustically. So we basically, this was
we
great.
were playing a song. I was playing acoustic.
Oh, right.
So we had
in the wilderness.
Everything stopped,
Yeah.
but the drums were acoustic and my guitar was acoustic. So we just kept playing.
It turned into an acoustic song. Oh, wow. That's amazing.
An unplugged set, right?
The weird thing is the audience, like, they got totally into it, and then eventually we found a piano down about 4 floors down. So the people on hand lugged the piano up. It wasn't in great tune or anything, but we played for about another half hour before we were out of hypergolic fume.
That's flexibility, adaptability. There you go.
And no refunds.
Those are the ones that you remember too,
Yeah.
though. It's like when it rains or you have some kind of natural thing that gets in the way of it. Or those are the ones that you remember because you really see what the band's made of. You know, how you get through that, and your audience. You know, they're willing to if they're willing to wait and stay through the weather, then we're certainly going to do it.
Absolutely.
Yeah, you mentioned earlier kind of the big picture of the entertainment of the audience. You know, Mars is really a destination, but getting there, we have to solve a lot of different problems that we hope to drive right back into life here on Earth, to make life on Earth even better for us as mankind by solving the problems that we go into this place. So Mars is a great draw because it really pushes us to solve some pretty tough problems. You know, water reclamation for third world countries.
Right.
We have to have pure water for this trip. So those kind of spin-offs are part of what we do as well in the big picture.
Yeah, for sure.
Those are kind of to your point, Lawrence, where you have all this technology and you have to worry about that, but then ultimately the goal for us as Mars, the goal for you guys is the entertainment of the audience. So everything has to work, but if it doesn't, you still have to achieve that goal, and that's where you're bringing a piano from 4 floors under to still achieve that goal, and it's working. You know? But I guess for space, it's just a teeny bit harder, I think.
I think so.
No extra piano.
I know, exactly.
That's one of the hardest
3D
parts,
printers.
right? Is like when you were, to your point, John, when you were saying for Apollo missions, we brought everything with us, right? No spare parts. I think a perfect example is Apollo 13, where things, were going wrong. We didn't have spare parts to fix things, but we still fixed them with the stuff we had on board, right? You're talking about engineers getting together in mission control and just laying out all the stuff that they knew was in the capsule and saying, all right, how can we fix this issue? We actually had something very recently too, where we had we were doing a spacewalk a couple months ago, right? And we were supposed to put a shield on the outside of one of the modules. Well, the shield got inadvertently lost. So there was 4 shields that we were supposed to put up, 1, 2, 3, and then there's this exposed part on one side, and we needed to cover it up. Well, it just so happened that during the same spacewalk, we took another cover off of another part of the spacecraft. So engineers took that cover and said, okay, how can we fit this cover onto this part? It was kind of, reminiscent of that time where you had to throw everything. All right, what do we have? What can we do? And they figured it out. They actually figured out how to lay this cover over that exposed part. Insane. And that's I guess our grand piano moment, right?
That's going to be a great day for the crew, though,
Oh, it really was.
for everybody.
Oh yeah, very
solve
satisfying.
that problem.
I think what's even better is during that spacewalk, I think we got everything done, right? I think all the missions were, even with that setback, we still accomplished the mission. We got everything done we needed to. It's pretty crazy. And that's, that's the stuff we got to prepare for. And that's the stuff you're thinking about, right? So, what happens? How many situations, John, are you thinking, okay, if this goes wrong, this is what we're going to do? How many times do you think that every day?
We will take some spares with us, okay? We're not just going to have the box of stuff we have. We know that over time some things break. And so what we're looking at is, what things are most likely to break, and we'll take spares for those and figure out ways to fix the stuff that goes wrong. So you can't assume everything's going to work just right. Mm-hmm. So a lot of the planning we do is figuring out what tools, what spares, what maintenance equipment to take with us to fix stuff that's going to go wrong, because that's all we got. No piano in the basement.
Yeah, he has a term called dissimilar redundancy. So electric guitar and an acoustic guitar,
that's
both
right.
on stage with you. And so we have something that builds oxygen and something else that builds oxygen over here in case this fails.
And, there's at a certain point you're going to have a lot of hardware on Mars. So it stands to reason that you could salvage parts.
Oh, sure.
And
And that's why very important to use the same size screws for everything, things like that.
Yeah.
Wow, amazing. So, before we wrap up, Lawrence, Tommy, do you have any sort of, just talking about exploring the solar system and all these different things, do you have any sort of floating questions that, just sort of popped up just based on the tour and this conversation? Anything that you were wondering, or maybe some thoughts about stuff that you were wondering but have a better understanding of now?
Well, what about, you always see suspended animation or like the is there any reality to that concept?
It makes for good entertaining.
Yeah, I'm an engineer. That's way out of my expertise.
Yeah, we'll have to bring a doctor in for that. No, I don't think we're doing much in those fields that I know of anyway.
Yeah, that is it's a good tool to get you places when you're telling a story.
Yeah.
Absolutely. But for the missions that you guys are planning for, you're talking, how will they get through those couple months? Because what you're talking about, I think the shortest time to get to Mars would be 7 months, right? Maybe closer to 9. What are they going to be doing in that time to sort of fill it?
So that's a great question. So they're going to be exercising like crazy because you want to arrive at Mars as healthy as you could possibly be. They're going to be, keeping the systems running, but they're going to be doing as much science as they can on the way too. Now, most of the science will probably be science on themselves, science on the humans, because we've never been in that deep space condition for that long before. There's also, we've actually been talking about them doing astronomy along the way, and so there will be real science that they accomplish, not just trying to stay healthy.
Do we have a good understanding of how the sky, I guess, will look on that transit to Mars? Will you be able to see a lot of different stars?
Yeah.
All right.
In fact, that's all you'll be able to see.
All right, cool. Because I guess the
Earth is going to become a little blue dot very quickly, and Mars will still be a little red dot out the other window.
Sun's getting smaller and smaller.
Yeah, the sun is just a kind of a bigger star in the sky, and everything else is just stars.
Amazing.
So,
but we have to think about weight, right? That's one of the things we have to think about. How much stuff can we bring with us on that journey to Mars?
Just enough. That's how much we can do.
So I'm guessing telescopes is part of that. Just enough.
Right.
Oh yeah.
Yeah. In space, in human space travel, mass is almost equal to cost, right? So for every bit of mass you add, you're adding cost because you have to boost it into space and get it to where you need to get it. So everything we do is all about saving mass. In the Apollo missions, they actually sawed the handle off of toothbrushes to save mass. Because mass was so precious back then. They figure you could use a toothbrush that has a little 1-inch handle on it as good as you can use a toothbrush that has a 6-inch handle on it.
Wow, that's
amazing.
Yeah.
That's check-in luggage right there.
Yeah, a little bit stricter restrictions than the TSA, I think, for spaceflight. Yeah. Any more dying questions before we wrap up?
I don't have anything. I don't know if I have anything pertinent to either of you guys, because I think the thing that impressed me today again was when Dan was talking about how much exercise. Like you're saying, you have to arrive there healthy. It just got me thinking a lot about how much our bodies change when we're away from this planet, and over such a short period of time. And that gets me thinking about what will humanity look like? What will we be like once we've spent a few years somewhere else? Like, we could actually physically change us, incredibly. One of the good things I heard is apparently your wrinkles go away. But I mean, as a species, it actually will change us.
Yeah, I think if there's people who actually are born and live on Mars within a few generations, you will be changed because you're living in a lower gravity environment your entire life, and
might even develop immunities to some of the things that you were talking about earlier, Glenn, about certain things. I don't know. I'm spitballing here.
Yeah.
If I have a chance, I'll talk to my great grandson one day, and I'll ask him a question.
Yeah.
Awesome. Well, guys, it's been an absolute pleasure to both talk to you on a part of this podcast, but also have you here today and kind of show you everything that we're doing. And it's just so exciting to see how engaged you were, and to it's been a real absolute pleasure. And of course, John and Glenn, thanks for talking about the real science that we're doing here at the Johnson Space Center. So
Thank you for having us.
Thanks for having us.
It's
Absolutely.
unforgettable.
Houston, go ahead.
Off of the space shuttle.
Roger, 0G, and I feel
The
fine.
shuttle has cleared the tower.
in peace for all mankind.
It's actually a huge honor to break a record like this.
Not because they are easy, but because they are hard.
Never Houston, welcome to space.
Hey, thanks for sticking around. So today we talked with Glenn Lutz, John Connolly, and some of the members of Styx just about exploring the cosmos and human exploration. It was a fantastic conversation, as you probably know because you've listened to the whole thing at this point. But if you go to nasa.gov, on the front page, you can see all of the things that we are exploring, all the places we are in the universe, both robotic missions and human missions. If you want to know just about exploring the cosmos from the perspective of human exploration, go to nasa.gov/Johnson. We are the Center for Human Exploration within NASA, so you can find all of the human missions there. On social media, we're very active, so just follow us on any of the accounts on Facebook, Twitter, Instagram, Snapchat, any of those guys. Look for NASA, and if you're looking for the story for human exploration, look for NASA Johnson. You can also use the hashtag AskNASA on any one of the platforms and submit a question or idea for an episode that we should do in the future. You can also use the hashtag HWAP, HWHAP, for Houston, we have a podcast. This podcast was recorded on July 28th. Thanks to Alex Perryman, John Stoll, Jenny Knotts, and Jeannie Aquino. And thanks again to Mr. Glenn Lutz and Mr. John Connolly, as well as Mr. Tommy Shaw and Mr. Lawrence Goen from Styx for coming on the show. We'll be back next week.